Test beta number 13 solution. Horizontal spring sits on a table and is fixed at one end. A box with mass m of 1.25 kilograms is pressed against a spring, compressing it through a distance of 0.20 meters and storing 9.2 joules of energy in it. So part A says find the spring constant. And from here we can say, well, the energy stored in a spring is 1/2 K times the extension squared. So we have 9.0 joules. 9.20 joules is 1/2 times the thing we're looking for times 0.200 meters squared. And if we solve that, we get 4.60 times 10 to the 2 newtons per meter, because we actually have 3 digits of accuracy. So we should do sig figs to keep 3 digits. And then part B says find the acceleration at the instant of release. And that's as simple as saying that we have some object, and at the moment there's a force on it coming entirely from the spring, and that produces an acceleration. So the net force is ma. So the spring force, which is ks, becomes ma. A is ks over m, which if you throw in the numbers is 460 newtons per meter times 0.200 meters over the 1.25 kilograms. So we end up with an acceleration of 73.6 meters per second squared. And then part C, which is a little complicated, says the box is released and the spring relaxes, propelling the box across a horizontal table into a quarter circular ramp. So as shown in the original picture, we have something like this. And originally the box has compressed the spring, but eventually it has not. And we know that this distance is s. The box goes to some height, and we're going to call that height h, and we'd like to find that h. And in essence, what we're going to do here is say that we're going to conserve energy and say the energy at the start equals the energy at the end. At the start, there would be some kinetic energy, and then some gravitational energy, and then some spring energy. At the end, there'd be some kinetic energy plus some gravitational energy plus some spring energy. I'm going to choose this to be the 0 for gravitational energy. So I have no kinetic and no potential, and I was told we had 9.20 joules in the spring. And at the end, we also have no kinetic. We have mgh for our potential, and we have nothing left in the spring because it's relaxed. So mgh equals 9.20 joules. H is 9.20 joules over 1.25 kilograms times 9.81 meters per second squared, and that comes out to be 0.750.